How's it going, everyone? Elvira Gonzalez here again. Today we're going to take a more practical approach of the DOM API. As a way to recap quickly, how do we get here, and how can we now so what is the DOM API? What it represents? What are the use case that as a UI specialist we can need to use the DOM API? Because most of the time we are going to rely heavily on frameworks, which is a wrapper around the DOM API that allows us to write user interface in a scale way. So you have, for example, React or Vue or Angular, Svelte, among all of this, right? But for example, when you need to create low-level libraries, so for example, virtualizations or DOM management, or perhaps you need to create your own components, like a chart engine or a video player, or you want to build your own portfolio with a minimal blueprints of any of these web apps. So the whole point of this is to recognize each one of those independent use cases, which if you're gonna work with large companies or for scale or for big enterprise, right? Most of the time you need to write is your own components for them. For example, in the case of chart engine, or video player, or any of these low-level libraries that interact with the DOM, and how important is for us to understand what is the DOM, what is the what is the tool that we can have access on the DOM, what are the DOM features that is exposed to us, as well as the way of how the DOM is organized. What is the mechanism of the DOM or the class hierarchy, right? Which is this. And then how now that is connected when it comes to actually do operations on that. So operations like querying any of these elements in the DOM, or adding or removing. And that's what we're gonna do in today's video, as well as to actually build is a very lightweight user interface, and the reason of going with that particular approach, as well as the best practice, and so on and so forth. So because this course is taught by Steve Ray, software engineer that has previously worked at JetBrains over 3 years, and then now he's currently at Meta, okay? Where the goal of today's video or this course is to understand the fundamental of system design for UI specialists as a way to build complex large-scale apps. Because at the end of the day, that's when the value is, to deal large complex things, to handle and manage millions, or to handle and manage big and multiple millions of records. So yeah, so this particular course is organized in this way, as a way to make sense of the introduction. What is the fundamental of the front-end design? What is the anatomy of the applications? And how now is by looking at the backend API and front-end. For our case, the front-end, how that is organized, which is how can we communicate to our APIs, as well as how we can manage and how can we store and manage the data UI data management, as well as the user interface patterns or interactions that we can build, or the most common user interface interaction that we can build to cover some of the most common use case in the most performing and efficient way. And then how we can now manage all of these assets in a way that doesn't impact the user experience. So that's why we're looking here at the core fundamental, DOM API, web API for complex UI patterns, virtualizations, application state and network connectivity, web application performance, and last but not least is that, hey, how are you going to design this system? How are you going to design this front-end system? Which is quite very interesting. Again, this is part of the feature that you're going to build for that. So in any case, because we went through describing his introduction, something that I really mentioned, and the core fundamental, which is if you're going to be now a UI specialist, because this is the reason why we're actually looking at this course, is to understand now how this thing works called the browser, and how now the browser treat the HTML elements, and for any time you want to add style to this HTML tags, the browser put a box around it. So CSS put a box around everything. So if you understand now how this box works and how they interact with each other, a lot of the time that can lead you to build more complex user interface in a very easy way. So that's why we look now at the box the box model, the box anatomy, as well as the box property, the size, where you have now intrinsic and the restricted, as well as the box type, which is the inline, the block, and the anonymous, and how now the block and the inline has its own particularly rules that apply to that particular boxes as a way of how they're going to be shown on the screen, and how each one of them has its own mathematics as a way to calculate their position and their size, okay, as well as how they interact with other elements. So for example, in the box, in the block, I'm not gonna dive deep into that. Today this is not about that. But how now they participate, because what we really care about all of this is that what is the reason of looking at the inline and block is because each one of them participate in something called the formatting context, whether it's block or inline, that each one of them has specific rules. And this formatting context now is the foundation of how this is connected to something called the stacking context. Because the key features of this formatting context is that we can now isolate all of these elements here, so they're not going to impact other elements, or other rules are not impact to this formatting context. As well as it is scalable, because you can put not only is block or flex or grid or inline or any other layout system that applies some of these formatting rules as a way to see how this element is going to look like, how this type of box is going to behave, whether it is with inner childs as well as with siblings elements and their parents, right? And that's something interesting, because this also leads to each one of these formatting contexts now are predictable, because they have this set of rules that they apply with, and then you can now build this complex user interface. So when you want, for example, when the browser need to know the position of these elements, it goes through something known as the normal flow, as a way to identify where all of these elements are they they are on the screen. And because if you want to change the normal flow of that, which is as a way to now add a new stacking context, as a way to now show elements on a different stacking layer, you can do that by using its position absolute and position relative, or any other CSS class property, my bad, that change or modify it is the particularly normal flow. So for example, CSS transformation actually do that. So position relative and position absolute has its own set of rules that are applied to this stacking context. And the reason of looking at this stacking context is that it not only provides a way of how you can isolate all of these elements inside of this layer, all right, but also you can now improve the performance on each one of those layers by using its transforms or some of this CSS property with hardware acceleration, with GPU acceleration. Because what happens is that anytime you modify the DOM or you interact with the DOM, anytime you modify the DOM, you are now causing is a reflow. And a reflow is part of this stage of the critical rendering path, which is the assembly line of how it's going to treat all of these HTML, CSS, and JavaScript files into pixels on the screen, as well as image and fonts, right? Into pixels on the screen. So you have now the document, you have the DOM, you have the CSS object model, which is merged into something known as the render tree that contains all the information needed for the browser. But now the browser needs to know where all of these elements is going to be put, and it is geometry. So where all of these elements are going to be put on the screen, and it is geometry. So this is the reflow process, and this is usually triggered by JavaScript. So when you change the geometry or the position of an element, you're effectively causing that the layout change. Therefore, now this is a CPU task. So the more you are changing the elements in an, as you can imagine, the more you change the positions, or the frequent you change the position or the geometry of an element, or if you have to change the geometry or the position of thousands of elements. So we got these two alternatives. Or you either apply some of this, or you change the position, exactly, or if you change the position or the geometry of thousands of elements, all right, or you apply very frequently operations on the CSS, or you apply frequent change of the geometry or the position of the elements here, what happened is that a lot of the time, right, what happened is that a lot of the time yep, what happened is that a lot of the time it will use CPU. So these operations can block the render thread. So as a way to prevent this, there are certain specific CSS properties that you can use as a way to optimize this pipeline, as a way to is talk directly to the GPU. So the way of how now the browser talk to the GPU, or how you can now do that, is through this composite layer. So this composite layer is the way of how now the browsers can represent elements, because this composite layer, back in the old days, is used only CPU, but now new browsers actually make use of the GPU. And this composite layer is a way for the browser to represent all of these elements, all of these elements in memory, and then talk to the GPU. So that's what we have, is the render object, where it has a representation of each one of those elements, each one of these HTML elements, all right, from the DOM tree, all right. But anytime you now change the normal flow, you create now a render layer, that is, well, the way of how now the browsers can actually optimize this rendering. Okay, especially when you're creating now this stacking context. But when it comes to now actually is use the GPU, you can use any of this 3D perspective transformer or 3D CSS property for video and canvas. Actually now tell the browsers to create this graphic layer as a way to now optimize the resource, as a way to now use is the GPU resource for that. And you may wonder why this is important. All right, why, looking at all of the theory and also put a practice of how the browser actually not only creating this formatting context and the stacking context, as well as the composite layers, and how now the browser is doing all of that as a way to talk to the GPU. A lot of the time this is useful when you need to actually create this low-level libraries, so virtualizations or DOM management, or for when you need to build is components, for example, charge engines or video player, or if you want to have a minimal blueprint portfolio without relying on all of these frameworks. And because of that, because those are the main use cases, and most of the time, perhaps if you're gonna work for a particular company, they want you to now build or reuse some of these existing libraries. So for example, they want you to now build is a low-level library, all right, that now are capable to modify all of these elements, or you want to create a genetic components out of this, and the genetic components that actually now allow you to use or utilize the GPU. So because of that, we need to look at what is the DOM, what the DOM actually represents, which is this document object model, where now this was designed to be language agnostic. So any other scripting language like Python, for example, can actually parse that, which is transform that into something in memory, and then you can work on that. And I think this is quite interesting, because most of the time we as web developers, we think that only the JavaScript can have access to the DOM, because, well, it was designed to bring interactivity to web pages, therefore to HTML documents, to DOM, to the DOM. All right, so that was interesting, and that's why we have now these global objects that we can use that, which is now objects that the DOM expose so you can now use that from JavaScript. That's one of the reasons I don't want these global objects, and I get it why a lot of people actually don't like global objects. It's because for immutability reasons, and in my case, it's for readability and being descriptive about the intent that you have when you write that code. But in any case, that's my opinion. So we have now the window objects. We also have the document, and from the document we can have access to the body or the head. And here, after that, we look at now how the DOM what is the DOM mechanism and how the DOM is made of, the components here. So because you have now an HTML that extends all of the functionality from something called the element class, that this class can have, this class is actually the DOM API, but this element it can represent not only HTML document but any XML language. So for example, SVG, that this in fact now extend from the node, which is actually the DOM API, right? Which is actually is our property of the DOM tree. Okay, so this node that contains relevant information. So I just want to take a closer look of the DOM node MDM. Okay, node. All right, which is now an abstract class, aka is a blueprint for any other subclasses. That most notables are document, element, as you can see here. You see element, document, and document fragment. And this is quite interesting because this node or this abstract class, which is now represent is this node, the DOM tree. And remember, DOM tree is a data structure that actually is useful when it comes to represent all of these elements. The reason of using a tree data structure is unlike most other data structures, or the way how now the computers see the reality that you're trying to describe, it's like, well, DOM, the tree-like structures, when it comes to access elements, when it comes to access, insert, remove, or search through that, on average is much more faster than other data structures. So for example, like hash or arrays or linked lists, or stack or queues. So, and I get it why a lot of, and I get it why, for example, the computer science is pushing the boundaries to actually take a look at the graph, all right, as a way to now you can let the computers to represent data, and from there you can now more useful, I get it, more useful and meaningful data that you can extract from. Okay, and I get it why, for example, Neo4j, Neo4j. All right, and I get it why, for example, Neo4j is a graph database and analytics. It's made of Java. All right. Is there an alternative for that? Exactly. Is there any alternative to this? 2010. God damn. $14 years in the making. Neo4j comes in 5 editions. Database research Andy Pavlov from Carnegie Mellon University has questioned graph database decision to abandon the long-standing relational model in favor of a custom model. In a few specific tasks. Neo4j sued Pure Thing, a small business that used a power created under the terms of GNU LGB to remove restrict common clause. DMCA. Ooh, they went to that. Ooh, they were sued, bro. Pure Thing is a software developing company, provides software solutions to government institutions and intelligence agencies. And they were sued, bro. And they were sued. And they were sued. Mm-hmm. According to them. Exactly, for nested data. Because after all, what you want to do with this kind of things, or this topography, because this is about looking at the relationship of all of this data. That's what they have now, relational database. But that's, yeah, even though that is, again, like any tool, everything evolves. And I'm going to dedicate slowly but progressively time to look at the Neo4j. You know, it's like, yeah, that's good, and I get it why a lot of people actually are pushing the boundaries for that, especially companies like this are doing this, because again, this is most likely for big companies. This is more likely for big companies. I don't know who is using it in 4G, Neo4j. Companies who is using Neo4j. Exactly, Comcast, USB, eBay, Levi's, and Adobe. 7 of the world's top retailers. Top retailers like Adio, eBay, and Abco rely on Neo4j to drive recommendations, promotion, and streamline logistics. AG. Michael Moore, Executive Director, Enterprise Knowledge Graph and AI. And I get it, man. Again, because this data topography is something that now can not only provide you relationship among different data, but give you is business intelligence as a way to make more informed decisions. So, but in any case, again, this go beyond the scope of this. But I know why understanding more about graph is something very important. This can be something that we can dedicate over the long run, which means is that the next year we can actually, or the next 6 months after that, we can dedicate time to actually put up practice this particular roadmap from that with. From the lead code, and I think why this is important as a way to solve each one of those problems. Absolutely, completely, and then especially to understand what is the value proposition of all of these data structures, right? And what is the usability of this? Yeah, the value proposition. So in any case, we got Node. Okay, so Node is this abstract class that now subclass implement that, and most notable subclass are document, element, and document is it represents any web page loaded in the browser, exactly, which is part of the global objects that you can have access. You can have access to window, to document, to the body, and the head, as well as the element, which represents any it represents is an HTML, all right, but this is the most general base class from which all elements which all element object that represents elements in the document inherit. It only has method that proper it only has methods and property common to all kind of elements. More specific, class inherit from elements. So for example, HTML elements interface is the base interface for HTML elements, similar to SVG elements, right? So the whole point of this is elements now represent is this base class that represents is HTML elements, which is documents, which is the most general base class from which all elements, objects in a document inherit. That's quite interesting here. That's somewhat interesting here, because you have now the HTML element. Okay, that makes slowly sense. You got node. Okay. And then you got HTML document, right? You got document. You got document. Document interface represents a web page loading in the browser and serve as the entry point into the web page content, which is the DOM tree. So is this document here. Extension of the HTML document. The document interface for HTML documents inherit from the HTML document interface, or it extend for such document. And then you got HTML document. For historical reason, window object have window.html property whose value is a document interface. So you can think of HTML document as an alias for document. So you have HTML document as an alias for document. And you can find documentation for HTML document member under the documentation of the document interface. So this is for historical reasons. HTML document. So you can think of HTML document as an alias for the document. Okay. As an alias for document. Okay. And document is one of these global objects that allow you to access to the DOM tree, which is the entry point of the DOM tree. Alright, so things started to slowly make sense. It's like you have now these global objects that are exposed to JavaScript by default. You don't have to import anything. That's one of the things that I don't like about that. I prefer to be more explicit. So you have now the window, you have the document, exactly the document, which is act as the entry point, is the entry point into web page context, which is the DOM tree. All right, and inside of this document you can access to the body and the head, right? But when it comes to now what is the way of how the DOM is organized, okay, because this is our global object that the DOM exposed, but wants to know how the DOM is organized, what is the structure of that, what is the class hierarchy. The entry point is so the entry point is the node, right? Where now the node is an abstract class which many other DOM APIs objects are based on, and most notably are the document. Okay, so this is the entry, this is now the base class, the abstract base class. I serve as a blueprint for other DOM API objects. DOM API objects like element, for example here, like the element here. Okay, so provide tree-like properties. Others like elements, HTML elements, or SVG elements, or HTML documents. That it has now, for historical reasons, this thing, right? Where the HTML document now has a reference to the DOM API. And also you have something called now the text node. The document here. So, but in any case, the document interface describes the common property and methods for any kind of document. HTML, XML, SVG. A larger API is available. HTML documents served with the text HTML content type also implement the HTML document interface, where XML and SVG documents implement the XML document interface. Extended markup language. Okay. And this XML document, okay, because this inherits from node, and the document property also inherit property from document. Okay, but the node is the abstract base class. Okay, the node is the abstract base class that a lot of these DOM API objects are based on or inherit that. Okay, so you have now elements class that can be used as a way to represent. This is a base class that allows you to represent is elements. All right, whether it is HTML elements or XML elements, or SVG elements as well, and document fragments as well, which is a lightweight version of the document. that store a segment of the document structure. But the whole point of this is that this is now, this node is the abstract class from the tree, okay, that is a blueprint for all the for elements, class base, or for documents, or for HTML. And elements here can be is whether it's an HTML element or an XML. Okay. Okay. Alright, so things are starting to slowly make sense here. So why this is important to actually look at this? Because especially once you know what is the hierarchy of the DOM, that is start from the node, and then this is the abstract base class, that you have now the elements that extend from that as a way to now represent is the DOM, and also this is used to represent other objects like HTML or SVG. Okay, the node also has something called the text node as a way to show is this context base, and also extends or from the node it serves as the HTML document, where now the HTML document has the window. The whole point of this is to then let it on recognize is how can we now query data, query elements on the DOM, insert elements, and remove elements. How can we do this kind of operations? So we have now several tools that allow us to query data. We have several methods to query data, and each one of them has its trade-off. I really love that word, bro. I really love that word. The DOM query, okay? Okay. No. So after understanding the class hierarchy, the DOM API class hierarchy, hierarchy as a way to understand. After understanding the DOM API class hierarchy, we need to know how to interact with them. What are the operations that we can do? So we got, what are the operations that we can do? And it is trade-off. This is something useful, especially if you're gonna work with this low level, but if you're gonna work with the DOM as a way to now integrate that with third-party services. Sometimes you need to actually touch this. So we get is now the DOM query, get element by ID, which is something that we are quite familiar. Okay. Let me actually take notes out of this.
So what is the DOM API? So to get the elements by the class name, because this is just basically accessing the object by its key.
Mm-hmm. So we got is this, right? So the time complexity and the read cost and the memory cost is actually O1, because this is actually like accessing the elements by its key. Okay?
The situation is slightly different when it comes to get elements by class name.
And it's also returned as an element. It return is this element class. Okay. Okay. The situation is slightly different with the get element by class name. Exactly. Get element by class name, or get element by class by tag.
So to get the elements by the class name, we need to actually traverse the whole tree. And the way the browser traverses the tree, it's use the DFS.
Mm-hmm. So because now, so because now we have to traverse. Yeah, because now we have to traverse the DOM tree. The browser use the DFS, which is deep depth first search, as a way to find the elements that match.
Approach. So it basically goes through the elements and finds all the elements on the page with the class text. So, and the time complexity for this is linear, so we need to go through all elements in the worst case. But you see there is a star here. This is because the browser is quite smart.
Mm-hmm. So time complexity. So time complexity is O n asterisk, and the asterisk means that the browser is smart enough that after the first time it will catch that.
And it utilizes the hash map when you try to.
Mm-hmm. So after the first traverse, it will catch that in a hash map. How do we know that that's true? Get element by class name. How do we know that that actually is what happened? But this is get element. No, get element by name, by tag name. No, but in my case it's like I get elements by class name. An HTML collection of found elements. The DOM standards. Document.getElement by class name. For web developers, non-normative. GetElement by tag names. List of elements with class name. My question is that how do you know that the behind the scenes? Provide links to look at it. even though they don't, in this documentation they don't explicitly tell how that works. They don't explicitly tell how that works. Yep, they don't explicitly tell how that works. But in any case,
to query things. So the first query will take some time.
It's better know that after the first traversal, it will catch that in the hash map. So subsequent queries, subsequent same queries will be
but if you execute the same query next time, the browser it will be almost immediately, because browser utilizes the caching mechanism. And one thing about
subsequent same query will be delivery in constant time. Do the catching mechanism. However, one of the thing with this, exactly. However, one of the thing with this query, with this method, is that return an HTML collection, which is a live, which is a live. This is a live HTML collection. Exactly, which is a live collection. Meaning it which is a live collection, meaning if you modify or if you manipulate this, you will essentially trigger reflow. However, one thing of this method is that however, one of the things with this method is that it returns an HTML collection, which is a live collection. Meaning, if you manipulate this, you will essentially trigger in reflow.
This method is also returns the HTML collection. And the HTML collection is the special, actually legacy collection, which has one interesting characteristic: it's live. So this means that if we modify the DOM tree, and for instance remove one element from the DOM, this will be reflected on our HTML collection. So, and that's why the read cost of the HTML collection is big O of n, because every time we need to read a single element, the browser will parse the tree again to verify its position.
So anytime the browser read it again, since this is a live collection, it needs to parse it again. Mm-hmm. To verify its position.
So this is a disadvantage of this thing. But on the other hand, the memory cost is low because the browser doesn't need to clone any objects. It just takes the already existing references. So you can utilize the HTML collection when you need to be low, like when you're low on memory, you need to use as less memory as possible. Okay, same is the same way works the get element by tag name. So there is no difference at all. It's just like it allows us to query things by the tag.
Mm-hmm.
So the query selector works slightly different. So it utilizes the CSS selector. So the time complexity depends on the selector.
Exactly. So we got is get element by ID. Get element by ID. We also have is or tag name, and then we got is now the query selector.
That we use. So the query selector works slightly different. So it utilizes the CSS selector.
Mm-hmm. Here we use is the CSS selector, and this is when now knowing about the selector is quite important.
So the time complexity depends on the selector that we use. So we always.
Mm-hmm. So the time complexity depends on the selector we use.
Base some tags on compiling the selector. So this means that the more complex selector you have, the more time it takes to compile it for CSS.
Mm-hmm. So the more complex selector you have, the more time it'll take to compile this, and therefore access to
and so the read access and the memory cost is big of 1 because we just returning the single element. And the querying mechanism, when we try to use the class names or the tags, it's the same as the DFS. If we use the ID, then we're gonna convert the statement to get element by ID instead. So one interesting thing about the query selector, and this is the query selector all, is because it returns a node list. The node list is another type of collection, but it's not live. It's just basically the copy of the elements. So what the browser does, it just copies the try to use the class names or the tags. It's the same as the DFS. If we use the ID, then we're gonna convert the statement to get element by ID instead. So one interesting thing about the query selector, and this is the query selector all, is because it returns a node list. The node list is another type of collection, but it's not live. It's just basically the copy of the elements. So what the browser does, it just copies the HTML objects, and this means that we pay additional memory cost when we do the querying. So it's not advisable to query too many things because you may end up having the memory spike.
With query selector all. Okay. With query selector all.
But the read access is O1 because you're just accessing the object directly from the array instead of traversing the tree again by maintaining the live collection. And the query mechanism is the same, DFS plus hashmap.
Of the elements, not a live collection. It returns a copy of the elements as a node list.
Quick summary. So the get elements by ID provide the best performance, but because the browser builds the cache, but you need to make sure that you utilize the ID space correctly. So it's basically anti-pattern to you to rely on IDs too much because the ID namespace is shared across your multiple components, and just make sure that you don't overuse IDs in your app. The get elements by class name or get elements by tag name provide a low memory overhead because it returns the live collection with just references to existing objects. But because the read access is high, so you need to make sure that you utilize this collection right. Because if you're going to loop for this collection, yes, it will convert to quadratic time. So and we don't want to do that in our app on the large set of elements. The query selector has slightly worse performance than get element by ID, but the browser itself heavily optimizes any CSS selectors. So in different browsers, you may get different results, but on average, it's very close actually to get element by ID. But the elements that are returned from this query do not represent the live collection. So if you remove the element from the DOM tree, you may end up having the stale element in your collection. Yeah, the same applies to the query selector all, but it also, because it copies all the elements, you don't want to query too many elements with this method.
Could you clarify the difference between the time complexity of querying versus the read cost?
Yeah, okay. So if we'll go back to get elements by tag name, for instance. So the time complexity it takes to go through the elements to find all the elements that we are looking for is big O of n, because we need to go through all elements in the worst case. But the read cost is also big O of n because we maintain the live collection. And when we maintain a live collection, this means the browser needs to verify that the element exists in the DOM tree. So
for example, here, the time complexity and the read cost.
Time you're trying to access this live collection, the browser queries the elements again to verify that the element is still present. That's why it can result to the time complexity being, in the worst case, we'll need to parse all elements. That's one of the reasons
why, for example, if you're going to actually iterate through these collections.
Again.
Is there a reason the query selector all returns the non-live element list compared to this one, for example, returning the live?
So the live collection is actually a legacy one. It's not
the live collection is actually a legacy one.
Recommended to use for normal cases. And I guess the query selector returns non-live collection because we needed to have some alternative. The live collection has more drawbacks, and if not used wisely, can lead to more issues. But in our application development, we don't really need to manage the live collections. And for most of the developers, the query selector is the better go because it doesn't have the expensive read access.
Why would query selector all impact memory? We're returning references to nodes which already exist in the DOM.
Not exactly. We actually return the copies of basically the browser creates a new object with the same values and the copies, and when you change the properties of these objects, it will impact the original object, but it's still, we have two separate objects basically with the same properties, and they are connected with each other through the proxy mechanism. So it's a slightly different. When we use the live collection, we actually guarantee we can actually reuse the real reference to the object instead.
When you're saying that the cache would make things faster next time, are you always sure about that? Because class names can be dynamic.
So you can't control that
Yeah,
because
yeah,
it's up
because
to
this
the
is
browser
the
engine.
browser
Like
engine works.
it's up to develop it. The same query methods can behave differently in Safari or Chrome, depending on how developers optimize that. For instance, Safari browser uses the WebAssembly compilation for the native selectors, while the Chrome doesn't use that because they find that the performance of existing query selectors is fine on average. So you can guarantee the same results, and it's up to the engine. So the logic of caching the element, the query selector is quite complex, and yeah, no guarantee.
Okay, so we got it, the query selector all, where now this return is a copy of the elements. Okay, this is query selector. Okay, so it returns the first element within the document that matches specified CSS selector or group of CSS selector. If no match are found, return null. The matching is done using the deep first pre-order traversal of the document. And I want to know what in the F is this. The pre-order depth, pre-order. Yeah, but this is pre-order. Okay. Root left and right. Left and right. Pre-order traversal, visit the node in the order of root, left, and right. Do you have left? Yeah, do you have left? Yeah, you have left. Alright, now, then right. One, two, four, then 5. If there is no node, is 3. Left, you don't have any left. Left, right, root. Go to the left, right, root. Okay, pre-order traversal is used to create a copy of the tree. Pre-order traversal is also used to get the prefix expressions of an expression tree. Of the document node, starting with the first elements in the document, markup, and interacting through sequential node by order of the number of child. If this specified selector match the ID that is incorrectly used more than once in the document, the first element with that ID is returned. CSS pseudo class, CSS pseudo elements will never return any element as specified in the selector API. And the selector API, holy F. CSS pseudo elements will never return any element. Okay. So it doesn't, okay. It only works with the selector, not pseudo elements. Returning a static, not live, node list representing a list of document elements that match the list group selector. This interface was an attempt to create an unmodifiable list and only continues to be supported to not break code that's already using it. Although they are both considered node-less objects, there are two varieties of node-less, live and static. Live node-less, in some cases, the node-less is live, which means that change in the DOM automatically update the collection. And okay, change in the DOM automatically update the collection. This is not performant. And the other is a static nodeless. In other case, the nodeless is a static where any change in the DOM does not affect the content of the collections. The ubiquitous DOM query method returning a static nodeless. This is good to keep this distinction in mind when you choose how to iterate over the items in the node list. Okay. The return value is this, or the query selector all. So the TLDR of all of this, right, is that from the developer perspective, it is
the read part is big O of n, because when you use a queries browser itself.
Exactly. So the TLDR of all of this is that for the developer perspective, query selector is much more okay. For the developer perspective, using query selector is much more useful and performant than get element by class name or tag, since it returned a live collection, which is the HTML document, HTML collection, where when every time you need to access to that element, the browser needs to traverse the collection again to know it is positioned, to know if it's still there by looking at its position. And not only that, when you change when you change something, okay, not only that when you change something, when you change an element in the DOM, you will get the HTML collection updated, which can be good or not, depending on the use case.
Heavily optimize any CSS selectors. Have slightly worse performance than get element by ID, but the browser itself heavily optimize any CSS select.
However, the browsers heavily optimize CSS selectors.
Selectors. So in different browsers you may get different results, but on average it's very close actually to get element by ID. But the elements that are returned from this query do not represent the live collection. So if you remove the element from the DOM tree, you may end up having the stale element in your collection. Yeah, the same applies to the query selector all, but it also, because it copies all the elements, you don't want to query too many elements with this method.
Could you clarify the difference between the time complexity of querying versus the read cost?
Let's move on to performance best practices. The first and the most obvious one, and the one overlooked the most, is that we can actually improve the performance of querying by simplifying the selector. So each time you use the complex selector, the CSS compiler needs to transpile this, and it takes more time. So you pay extra tax on using the complex selectors. So you may notice that it's not significant. So you may pay like 5 milliseconds on the query to compile the selector, but
yeah,
all these things are accumulating. So if you do hundreds of queries, so it will result maybe to 50 milliseconds on average in the delay. So, but if we combine all possible optimizations with this one, the results can be quite significant. Although the IDs is not the best practice, you still can utilize IDs for the core container when, for instance, you need to query the element from the very large tree. So
exactly.
If we have some DOM tree that has 10,000 elements, if you query from HTML, then you need to go through 10,000 elements on the first query. But if you, for instance, could select this section with an ID, and then you know that this operation should be repeated multiple times, then you can just provide an query from this section, and it will be just one operation. So next section is removing elements. And before we jump to that, and you could provide an query from this.
And performance best practice. Okay. This is not DOM performance best practice. DOM performance best practice. There you got it. That's right, DOM performance best practice. Finder. Share. There you got it. Document. Oh lol. Screen Studio. Mount that. Jesus. Where do you store it?
section, and it will be just one operation. So next section is adding, removing elements. And before we jump to that, any questions so far?
So you talked about these, like understanding the differences between these methods being useful if you were going to build something more low level. If you're working on something that is using a framework like React or Angular, are there recommendations you would make for improving performance or like knowing what their methods are using under the hood? Or do you just kind of trust that the library authors have spent a lot of time thinking about it?
Yeah, when you utilize any library that manages the DOM for you, you just rely on this library. The only way you can possibly think, you may use your the DOM API within some effects in the React when you need to query things. This is the place where you could optimize potentially, but trying to optimize a React is not a good idea because it's quite complex inside.
Is the cost of CSS only during compile time? Wouldn't the runtime of complex selectors also be performance?
No, actually, you compile this. First, you compile your styles in CSS. This compiled when you initiate the page. But when you execute the JavaScript with some query selector, this is dynamic selector. This means it should be compiled in runtime. So you pay the cost every time you execute that. Okay? So let's now understand how we can add or remove elements. And when it comes to adding or removing, every method is bad. So basically, we don't have a good. So the performance impact is always significant. So there's no good method to insert the data because every time we modify the DOM, it triggers the reflow. So in our application, we want to minimize the reflow operation, and so but there are a few methods that are particularly impact the performance. The first one is inner HTML. So when you use the inner HTML, you basically set the HTML, the element. The browser needs to involve the HTML parser to compile your HTML again, to do a full reflow, validate your HTML, and so on. So you pay the cost of the parsing. Same applies to insert a JSON HTML. Because we use the raw HTML, the browser still needs to parse that. But if you need to modify the DOM, make sure that you don't utilize the inner HTML too often. It's okay to use this once per initialization, but if you expect it to insert elements dynamically, then it's better to utilize the insert a JSON element or append child because it takes the compiled HTML object already and just renders this on a DOM. And we can see how it works. So the method is pretty flexible because it accepts the position where we can insert the element. The first one is before begin, which basically insert the element before the target element. So we can try to insert that and the element is inserted. So the after begin will give you the first child position, while the before end will render element as a last child. And after and will give you the position right after the target element. So this method is very flexible and can be used almost anywhere.
And this is inner adjacent element, right? So if we now take a look at the inner, inner adjacent, no inner HTML, but insert, my bad. It's insert adjacent element. Oh, and then you can provide now is where you want to put that. Before the element, just inside the element, before it is before it is first child, before n, just inside the element, after it is last child, and after n, after the element. Only valid if the element is in the DOM tree. And followed by the text. The string to be parsed as HTML or XML and insert into the tree. But this is insert adjacent HTML. But if I want to insert adjacent element, the element to insert into the tree. So you don't need to parse anything here.
So this method is very flexible and can be used almost anywhere. Then how do we remove elements? So removing elements can be done through the remove method. Basically, we need to have a reference to the object.
But this document get element by the return, if I remember right, an element. Exactly. And the element is the one that extends from node.
And we can also reset the whole HTML by setting the empty string. Utilize the method to use you
kind of something that is.
Adding on removing elements. So adding and removing elements, where you have now this. And the other is removing an element. And removing elements. So that'll be all for this video. Take care. Bye bye.